The characteristic equation of a negative feedback closed loop control system is f of s equals to 1 plus g of s dot h of s. The equation is 6s5 plus 5s4 plus 3s2 plus 7s plus 10 equals to 0. Okay. The characteristic equation of a negative feedback closed loop control system, whether this equation is stable or unstable, right? Now, according to the Routh-Hurwitz criteria for closed loop stability, this is important. The criteria for the closed loop stability, there are two conditions that needs to be satisfied. And what are those conditions for stability? Well, the first condition is the coefficients of power of s. The coefficients here, 3, 7, 1, should be non-zero. And they are non-zero, or should exist, and they exist, right? Now I'll come back to this point again later. They are non-zero, but whether they exist or not, that is a question. The second condition is coefficient in the equation should be of the same sign, which is also the case. You got plus here, plus here, plus here, and plus here. Now notice here in this equation, the cube is missing. S cube is missing. You got 5, 4, 3 is missing, 2, and 1. And that is where this condition fails. It does not exist. Now, because there's no S3 term in the characteristic equation, and hence the system is going to be unstable.